On Saturday morning, Malachi will begin a camping vacation, and he will return home at the end of the first day on which it rains. So we leave Saturday morning. And at the end of the first day on which it rains, we're going home. So I guess if it rains on Saturday, Malachi will go home. If it's sunny on Saturday and then it rains on Sunday, then he'll go home at the end of the day on Sunday. If on the first 3 days of the vacation the probability of rain on each day is 0.2, what is the probability that Malachi will return home at the end of the day on the following Monday? So we've got to get Malachi home at the end of the day on Monday. So how can this happen? Well, we're told that he's going to return home at the end of the first day on which it rains. So if we're going to get him home at the end of the day on Monday, well, Monday has to be the first day on which it rains. That means the only way to get what we want is to have it sunny, or to have it not rain on Saturday. I'll say N for not rain. And then he can't go home on Sunday, so we've got to have a not rain on Sunday. And then we have to get him home on Monday, right? We're not asked what's the probability that he will stay at least until Monday. We're asked what is the probability that he returns at the end of the day on Monday, so we need to have it rain on Monday. And this is the only way to get what we want, which is good news, because that means we don't have to think of other arrangements or anything like that. We can go right to considering the numbers. So, for our first event here, what is the probability that it does not rain on Saturday? Well, we're told there's a 0.2 chance that it does rain. I guess that means there's a 1 minus 0.2 or a 0.8 chance that it doesn't rain. Same thing on Sunday, right? If there's a 20% chance of rain, that means there's an 80% chance of not getting rain. And then Monday, same thing. There's still, well, now we're getting rain, so there's a 0.2 chance of getting rain. So, well, how do we get all this information combined? What are we going to do with these numbers if we're saying that all three of these things need to happen together? They have to happen in sequence. And, well, in probability, one thing and another thing occurring means we multiply the individual probabilities. So, multiplying these numbers out. Let's see. And I want to make life easy, so, well, I guess I'll ignore the decimal points at first, and let's just see what happens with that. If we ignore the decimal points, we've got 8 times 8 is 64, times 2 is 128. And, well, actually, let's glance at the answer choices, and that is enough. There's only one answer. I mean, there's going to be a decimal point in here somewhere, right? But we don't need to know exactly where it is, because there's only one answer choice with these numbers in this sequence. So we can see that answer choice B is our answer. I guess there could have been, a 0.0128 in there, or a 0.00128. So if we did have to figure out the decimal place, well, we can go back to that rule for multiplying decimals, which is that, what's the best way to say this? If we multiply decimals, or multiplying decimals, we can say conserves the total number of digits to the right of decimal places. Maybe just illustrating it is better than thinking of it as a definition. We can say on the left of the equals sign, we've got 1, 2, 3 digits to the right of decimal points. 3 decimal places, we can say. So we need 3 to the right of the equals sign. So 3 on the left means we're going to need 3 on the right. So 1, 2, 3, 0.128, which, well, we already know that leads to answer choice B.